Welcome to lecture number 6 of machine learning. The topic is continued from the previous lecture number 5. So this is the point we are going to predict. That is the height h for the Gaussian curve. If the points are like making a Gaussian curve, so that will be tau. These are some of the points x1, x2, x3, x4 on the Gaussian curve. It resembles the Gaussian curve or function, but not its exactly Gaussian density. Now what we have to do how to choose the width of this Gaussian density, not called but Gaussian curve. So that is the difference between the statistics terms and the machine learning term. Or otherwise, it is decided by what's the neighborhood of points you should use to fit. So for that detail or width, how closer the points are chosen, so its width depends. If the points are very close, its width is very close. If the points are away, the width is too much. So it is decided by what's the neighborhood point. So tau is the bandwidth parameter. Wi continued from previous lecture, exponential this value. So here tau decide that it's narrower or wider. In short, that is the tau. Its tau decides that it is narrower or wider. Tau has effect on overfitting and underfitting. Sometimes sometimes may be the curve we obtained. There are many versions of this algorithm, but the popular version is above discussed. So there are other versions. Some people may observe that there are other versions which we have not discussed, but we are discussing the famous version of this algorithm. If you have 2, 3 or 4 dimensional data with thousands of examples, then equation A is still valid. That is the equation A. It is still valid with thousands of the examples are given, or even the 4-dimensional data is also present. Now question is, why squared error is used? Why not other powers like fifth power or absolute values? Answer will be in the coming lecture. So here is the topic or point from the first lecture is the shop price. So I am also taking that point here. So that is epsilon I, error terms. That is called unmodeled effect or random noise. So if the shop price may also be added with the good mood or bad mood of the customer. If the mood of the customer is good and the cost is much higher, customer may purchase. If the mood is not good, then the price of the shop may decrease. So that is epsilon I is the error term. So epsilon I is distributed Gaussian. It would mean 0 and covariance sigma squared EI is pronounced as distributed with stripped 0 and sigma square. So normal distribution and Gaussian distribution are one and same thing from the machine learning point of view. So these terms may be used alternatively. So that is now that will become the term with epsilon I. That is the error term. So sigma controls the width of the Gaussian. So now here that is the term sigma that is controlling the width of the Gaussian. So some assumptions which are very necessary to use this. First of all, epsilon error terms are IID, that is the statistics term, independently and identically distributed. So that is an assumption. It means that the error term of one shop is independent of the other shop. That is not true. You people know that if the one shop price is increasing, the nearby shop price is also increasing. If a plot or property price is increasing, nearby price is also increasing. If the price of one property is going to decrease, then the nearby property is also going to decrease. So that assumption is actually not true, but for the calculation we assume that assumption. Also, if a shop on one floor is high, then the nearby shop price is also high. It is necessarily not true. Sometimes the shop is on the front, other shop is at the back of the floor, that price may decrease. So the price of one shop is high, then the price of other shop will not be high according to the conditions. So it is also not true, but these are the assumptions and we have to assume it. So that is the end of this lecture. We'll come with another lecture. Thank you.